everyone. Welcome to Dharma Foundation. In the previous class, we have learned few concepts from complex number. In this video, we will try to learn few more concepts from complex numbers. First concept is geometrical form of complex number. Geometrical representation. Geometrical form of complex numbers. As we know, let's z is equals to x plus iy. We have to represent this in the geometrical form. For that, I am taking geometrical coordinate axis. This is x and this is y. In the complex number, this plane is called as Gaussian plane. Or complex plane. And let's take this complex number. So we can write this complex number in the form of x comma y. This means this equals to x plus iy. So I'm taking one point in this Gaussian plane, this p x comma y, and this is origin. I'm drawing a line from origin to point P and one perpendicular line to the x-axis and another perpendicular line to the y-axis. So this distance will be x and this distance will be y. So this will become, according to Pythagoras theorem, this distance, this OP distance will be, OP is equals to under root of x square plus y square, according to Pythagoras theorem. As we know, this is the value of mod z. Modulus of z is equals to under root of x square plus y square. So we can say this hypotenuse as mod z. So this is how we can represent complex number in the geometrical form. Let's see the other type of forms of complex number. Those are trigonometric form, and polar form, and modulus amplitude form. So, as we have seen earlier, in the Gaussian plane, I am taking a Gaussian plane and marking one point P x comma y, and this is y and this is x. So, and I am taking z is equals to x plus iy. I am representing this in the trigonometric form. How we can represent in the trigonometric form? Z is equals to r into cos theta plus I sin theta. Here cos theta is equals to x by under root x square plus y square, and sin theta is equals to y by under root x square plus y square, and here r is equals to under root x square plus y square. So here in the Gaussian plane, so this is y and this is x. So this will be r is equals to mod z. So from this we can say that in the trigonometric form, z is equals to r into cos theta plus I sin theta, where cos theta is equals to x by under root x square plus y square and sin theta is equals to y by under root x square plus y square, and r is equals to x square plus, under root x square plus y square. This is how we can represent in the trigonometric form. And this r into cos theta plus I sin theta, this is the polar form. Here amplitude will be, this is modulus, right? Modulus mod z is equals to r. This will become x square plus y square. This is the modulus, right? Now we have to find the amplitudes. Amplitudes from the positive x-axis. This is making theta direction. Amplitude is, this theta will be, theta is equals to tan inverse y by x. So this is the amplitude form of complex numbers. In the geometrical form, if mod z is equals to 0, in geometrical form, mod z equals to 0, that means you will get under root x square plus y square is equals to 0. If mod z is equals to, now let's come to the argument and its properties. So in the Gaussian plane, I am taking Gaussian plane. In the Gaussian plane, this real number is represented as x and this imaginary part is represented as y. And I am taking a point on this Gaussian plane P, x comma y. So this is y and this is x and this is mod z. And this will make theta degrees from the positive x direction. Then theta is equals to, as I told before, tan inverse y by x. So this we can call as argument. Now I am taking z is equals to x plus iy. If tan inverse y by x is equals to 0, when you will get 0 tan inverse y by x, that means, that implies y by x is equals to tan 0. Tan 0 value is how much? 0. That means y by x is equals to 0. That means 0 by 1. So if you compare this, y equals to 0. X will be 1. So from that we can say that this is purely, if tan inverse y by x is equals to 0, then z is purely real. Again, if what we can say, if x is equals to 0, then argument will be theta is equals to tan inverse y by x. X value is 0. That means tan inverse y by 0. So this means tan inverse anything by 0 will be infinite. So your tan theta is equals to infinite. So this means, what is the theta value here? Where you will get infinite? Infinite will get at pi by 2. is equals to theta is equals to pi by 2. So that means if theta is equals to pi by 2, we can say that this complex number is purely imaginary because this real part is 0. So that we can say that this complex number is, this z is purely imaginary. From this what we can conclude is, if the complex number is purely imaginary, then we will take real part as 0. And if the complex number is purely real, then we can take imaginary part as 0. Again, now argument of z1 into z2 is equals to argument of z1 plus argument of z2, and argument of z1 by z2 is equals to argument of z1 minus argument of z2. Argument of z bar is equals to minus of argument of z. How we can derive this? Let's say z is equals to x plus iy. Argument will be tan inverse y by x. Now z bar will be, your conjugate will be x minus iy. Argument equals to tan inverse minus y by x. We know that tan inverse of minus theta is equals to minus of tan inverse theta. From the inverse trigonometric function, this is the formula, we know that. That means this will be minus of tan inverse y by x. So from this what we can conclude, this is tan inverse of y by x is argument of z. So this will become minus of tan inverse of y by x. Another property is argument of 0 is not defined. Not defined or infinite, whatever we can call it. So these are the some properties of arguments of complex numbers. Now let's move to the principal value of argument. For that, in the Gaussian plane, this is x and this is y. So I am taking this point x comma y here. So what I am doing here is, if I measure this angle in anti-clockwise direction, then this principal value will be in positive. If I calculate this principal argument, if complex numbers lies in this fourth coordinate, that means minus x comma minus y. So if I measure this argument in clockwise direction, that means your argument will become negative. So if argument is from positive x-axis to the anti-clockwise direction, then argument will be positive. So if you measuring, if angle is clockwise direction, we take principal argument as negative. So these are the some few properties of principal value of argument. Now we have to represent this principal value of arguments in the coordinates. Let's take in the first coordinate, your principal argument will be in first coordinate. So how we can represent complex number in first coordinate? Z is equals to x plus iy. So in this first coordinate, x is greater than 0 and y is greater than 0 in this first coordinate. So here your principal argument will be argument only. So let z is equals to x plus iy. So in the first coordinate, x is greater than 0 and y is greater than 0. Then principal value if you take this alpha, this will become theta, this angle. In the second coordinate, now in second coordinate z is equals to, this is the second coordinate, right? So in second coordinate, so x is negative minus x and y is positive y. So in second coordinate, minus x plus iy. So in the second coordinate, x is less than 0 and y is greater than 0. So we have to calculate the principal argument from here to here. Here x is making negative direction. X is making from negative x-axis to positive y-axis. And if you take from the positive x-axis, we are taking anti-clockwise direction. Anti-clockwise direction means you will get positive values. Now we have to find the principal value of argument. Principal argument will be is how much? This one is we have to find, right? So if you take this whole, this is forming a semicircle. This semicircle angle is pi, and we have to find this angle, right? So this angle means we have, if you subtract this angle from this whole angle, you will get this angle. So that means pi minus theta. So this will be your principal argument in second coordinate. Now let's go to the third coordinate. So in third coordinate, what you will get? You will get x less than 0 and y less than 0. Here you have to calculate this from negative x-axis to this one, right? So this is clockwise direction. So I have to make anti-clockwise direction. If I have to make anti-clockwise direction, the principal argument will be minus of pi minus theta. So this one is right. So upper one is pi minus theta and this one is minus of pi minus theta. Now I am going to the fourth coordinate. In fourth coordinate, your principal value here in fourth coordinate, x is less than 0 and y is less than 0. In this, you have to measure this angle, right? If you are using measure anti-clockwise direction, then your principal argument will be minus of argument. So alpha is equals to minus theta. So this is how we can measure the principal arguments of complex numbers in geometrical form. Vector form of complex number. I am taking a Gaussian plane. In Gaussian plane, so this is x direction and this is y direction. I am taking a point on Gaussian plane x comma y. I am drawing a perpendicular lines to the x-axis and to the y-axis. So this distance is y and this distance is x, and this distance will be under root x square plus y square is equals to mod z. OP. Vector form. So this is how we can, vector form means OP is, if O, I am taking this as A, this as B. OA is equals to x. OA has this x direction, positive x direction, and OB. Vector has direction, so this represents direction of vector. This OB is equals to y. So, and now resultant will be OP. OP is equals to under root x square plus y square. So this is how we represent complex numbers in vector form. Now let's take two vectors of complex number. So I am taking one complex number here z1 and here z2, and this complex number is here z3 in the Cartesian, in the Gaussian plane. So I have to find the angle which making z2 to z3. How we can measure this angle? This angle theta is equals to argument of z3 minus z1 by z2 minus z1. De Moivre's theorem. De Moivre's theorem says that if n is any integer, n is any integer, then cos theta plus I sin theta power n is equals to cos n theta plus I sin n theta. Let's take one example. Cos theta plus I sin theta whole power 3 is equals to cos 3 theta plus I sin 3 theta. Now let's come to the Euler's theorem. Euler's theorem says that e power I theta is equals to cos theta plus I sin theta. One more, e power minus I theta is equals to cos theta minus I sin theta. So Euler's theorem says that e power I theta is equals to cos theta plus I sin theta, and e power minus I theta is equals to cos theta minus I sin theta. Now, if you add these two equations, so in the right hand side, e power I theta plus e power minus I theta, this will become cos theta plus I sin theta plus cos theta minus I sin theta. What will get here? This I sin theta will get cancelled. This will become 2 cos theta. That means 2 cos theta is equals to e power I theta plus e power minus I theta. Now cos theta is equals to e power I theta plus e power minus I theta by 2. So if complex numbers given in the Euler's form, then we can write the cos theta is equals to e power I theta plus e power minus I theta by 2. Now let's subtract these two equations. That means e power I theta minus e power minus I theta. This equals to cos theta plus I sin theta minus cos theta, minus into minus plus I sin theta. Here this cos theta and cos theta, these two will get cancelled. One, and e power I theta minus e power minus I theta is equals to 2I into sin theta. Now sin theta is equals to e power I theta minus e power minus I theta by 2I. So this sin theta will represent imaginary part, and this cos theta is representing real part. So this is how we can find real part and imaginary part from the Euler's theorem.